Hi friends, we are looking at section 7.3 and we're looking at similar triangles. So here we're going to start off with this postulate, and this is one that you guys discussed. Basically, if you've got two triangles, and you know that two of the angles are congruent, as we have here with triangles ABC and FG, no name. Let's see, maybe I cut that off in copying. So it's got to be FGH. There we go. So if we've got these two triangles and you know two angles are congruent, clearly the third side must be congruent, right? We know that. And then you know that just by having three angles, and this is the only figure that does this, just by having three angles congruent, you know you've got similar triangles. So only with triangles, three angles congruent are sufficient. That's sufficient information for proving that those two triangles are similar. So if you take a step back, you don't really need three angles. You only need two angles because the third one is implied. Got me? That's what this postulate is saying. Let's see if we can apply it using it in example 1. So determine whether the triangles are similar. If so, we're going to write a similarity statement and explain our reasoning. We'll do a lot of this verbally. So what I'll do is figure out what the missing angle is. So if I have 57 here and 75 here, I know that all of those angles need to add up to 180. Similarly, in this triangle, 48 plus 57 plus some other number must add up to 180. Already I get the sense that it's not going to work out, but let's see if my suspicion works. So I'm adding and I'm simplifying both sides, and I'm going to subtract 105 from both sides as I know I should. And when I do that, I get that this box over here is equal to 75. Of course, I could have used a square or probably an X for a variable would have made better sense. So I've got that. So 75, maybe it is going to work, right? There's 75, and if this is 48, which it has to be, let's just prove it to ourselves. So I'm going to subtract 132 from both sides, and when I do that, I do indeed get 48. Golly gee willikers, they are similar. Right? So this is 48 here, and this is 75. So given that information, I can say that they're similar, and the similarity statement would name each angle in order. Let me start with smallest, middle, medium, and large. So triangle JLK is similar to triangle smallest is O. So MP. So that's part A. Let's check out this side. If these guys are similar, let's write the similarity statement. So way back in the day, we knew that these were, I don't know if I call them bow tie angles, but we know they're vertical angles, and vertical angles are congruent. And having parallel lines, parallel lines cut by a transversal, remember those? So I'm going to extend them just so I can kind of get the feeling of what we used to talk about back in the day. And I'm going to use this line and call this one a transversal, just for now, and see if I can see anything. Oh, look at that. Boom, bap. Alternate interior angles. Yeah. Never thought you'd say that with that hip tone. Alternate interior angles, baby. No, just me. All right. So this guy over here as well is similar, is a transversal, and I can rock out on alternate interior angles here too. If you see that. You see that? Right? Because these two angles are created by the parallel line and this guy here. So you can already see that all of these angles are congruent, and therefore we do indeed have similar triangles. And so what triangles are similar? I will tell you. So let's start off with SXR. There we go. SXR. And then I'm going to do single, double, triple. So I'll do STW. Beautiful. So we have two beautiful theorems here. We're going to talk about triangle similarity. And so side, side, side. So if you didn't have any information about the angles at all, like, you could prove that two triangles are similar if the corresponding sides are proportional. And I think you guys kind of assume that. But this is only true for triangles. Like other polygons are a little bit more complicated. You need a little bit of a mixture of both things. But for triangles, we can prove simply that the sides are proportional. If all the sides are proportional, woohoo, we got similar triangles. That's what 2 is saying. 7.3 says, hey, you can prove if two sides are proportional and the interior angle or the included angle is congruent, then you've got some similarity. And I think you're feeling the similarity to the congruence theorems, SSS and SAS. We used those back in the day for congruence, right? And now we're using it for similarity. Remember, we're not proving that the sides are congruent, just that the sides are proportional. So we'll imply this logic here in example 2 by taking a look at the figure. So determine whether the triangles are similar. If so, write a similarity statement. And again, we'll verbally explain our reasoning. Clearly, these guys are vertical angles, so I've got that. And as soon as I have an angle and some sides, I'm thinking I'm going to try to do what we learned just now, which is side angle side. So let's try side angle side. So I'd like to prove that, or check out and see if this side is proportional to this side as this side is proportional to this side. So I'm going to check that out by doing minor calculations. So I'm going to do, I generally do small to large. I don't know why, but that's just how I roll. So you could obviously do it other ways. 5 to 12.5, is that equivalent to 8 to 20? And so what I'm going to do, I can't really reduce this, but I can reduce this. And when I reduce this, I'm going to get that this is going to be 2 to 5. So is 5 to 12.5 the same as 2 to 5? Let's see. Cross multiply. 5 times 5 is indeed 25. And 12.5 times 2 is indeed 25. Woohoo! So I have that these two triangles are similar by side angle side similarity theorem. And furthermore, I'm going to tell you about their similarity. So they are similar. Let's name the angles. Let's start with R, and I'm going to travel down the blue side. So RPQ, RPQ. And I'm going to start here, RST. So those guys are similar to one another. Cool beans? Hopefully so. All right, let's take a look at this one. What the? Okay, so I have these two triangles that are nested in here to one another. And so I see I've got triangle AEF and ACB. Hope you see that too. And I'm anticipating, let's see, let's do it that way. Triangle ACF. No, that's wrong. Triangle ACB, and the other triangle I'm dealing with is triangle AEF. All right, thank you. And I'm going to see if they are similar. And so basically 8 to this side, 12, and 10 to 15 is what I need to prove to be congruent. And if they're proportional, then I'm good, because angle A is equal to itself, right? So, and these are, I think we've had this before. 8 times, well, actually we reduced it, but 8 times 15 and 10 times 12 both give me 120. So 120 is equal to 120. If I do a little cross multiplication magic for you, it's delicious. All right, so we have this. Haha, it is true. And again, by side angle side. You know how our textbook is. Our textbook probably wanted me to like do 5 is to this, is this is to this, is this is to this, instead of using the handy angle in here. But I outsmarted them. And so can you, as long as you do it legally. So SSS would have worked here, is my point. Let's go on. We're doing so well. Here's a standardized test example. So the answer choice is here, which is sometimes helpful, but sometimes it's just confusing. Let's see how we get through this. In the figure, the angle ADB is a right angle, as noted. Good. Write the following. Which of the following would not be sufficient to prove that these two triangles, let's look at them, ADB and CDB, are similar. All right, so we're trying to focus our attention on this triangle here, because there's, about 3 triangles here, right? The larger one too. But right now what we're looking at is these guys here. And I'm going to just highlight them for the purpose of focusing. Good. So I've already got these two angles congruent. So I already know a couple things. But what if they told us that AD is AD to BD is the same as CD to BD. Would that be enough to prove that these guys are proportional? And hopefully you can see that yes, that would be. So that's not what we want. We want something that's not enough. So that would be enough, so we've got to move on. So would it be good enough to prove that ABD, angle ABD, is congruent to angle C out here? Remember earlier on, we talked about if we have two pairs of angles congruent. So if this is 90, this guy has to be 90. And then these two being congruent, this is again enough. So we don't want that. Let's look at B. So AB to BC is congruent to, let's see, AB to BC is proportional to BD to CD. I need to think about that. So this angle to this angle, this side to this side, and then this side to this side. This one does not look like enough for me, so I'm going to hold on to it for a second, but I need to check this one. I want to be sure that I can isolate this one as enough, because if this one's enough and this one is causing me confusion, then I know that this is the guy. Oof. Isn't this a harder problem than it seems for a problem with the answer on the page? Just saying. I want you guys to think about that when you're preparing for your SATs. Like, it's not always about sometimes you have to do the process of elimination as we're doing here. That's the end of the story. All right, so let's look at this. AD is to BD as BD is to CD as AB is to BC. Nope, this is totally enough to prove it. This is like SSS, right? This was the AA postulate here, and this one was the side angle side postulate because we've got the two angles there. So clearly this guy is the red herring, is the bad guy. D, get out of here. So you're the one that's not helping us. So look at how mathematical logic can extend. So we actually have properties of similarity. So there's a reflexive property of similarity, equivalent or the same triangle is similar to itself, which makes sense. Angles are equal, sides are proportional. Symmetric property, if you've got two triangles that are similar and then another triangle similar to one of those triangles. Oh, no, that's not this. Sorry about that. If one is similar to another, then you can flip it and the other is similar to the other. Kind of obvious, I would say. But anyway, that's the symmetric property. And then we have the transitive property, which is what I was going to talk about. If this one is similar to this one, and this guy is similar to yet another one, then the first one is is similar to the third one. I can speak, and I know you guys can read, so I'm sure that made sense. In this problem, we're asked to find BE, that's X, and we're asked to find AD, which is 3 plus Y. And so what I'm doing is just observing the fact that indeed I do have similar triangles. This triangle and the larger one are similar because they have at least two angles in common. And you can see parallel lines cut by a transversal produce corresponding angles that are similar. So ABE is similar to ACD, and now I'm going to use those facts to solve my problem. Notice the scale factor is 3 to 5. And notice that we can find X by saying X to 3.5, right? So small to large, small to large. And then I'm going to similarly do that Y to Y plus 3. Small to the larger side. Y to Y plus 3. And so that should give me the ability to do the thing that I need to do, which is to solve this problem. So I'm going to cross multiply, as you know I will. And with a little bit of work, we get that X is equal to 2.1. Similarly, I need to set up, and I'm going to use this one and not the decimals. So 3 to 5 is equal to Y plus 3. And I'm going to cross multiply. And when I work that through, making sure I put this in parentheses and using distributive property solving, I get that Y is equal to 4.5. Since we were looking for AD, I added 4.5 to 3 and got 7.5. And since X was just BE, I got 2.1. So here we go. Haley is 5'3", 5'3" inches, and her shadow, which is this dark thing down here, is 3 feet. And she is next to this Superman roller coaster. Ah, save me! And this Superman roller coaster has a length in terms of its shadow of 40 feet. We want to estimate the height of the roller coaster. And you're going to have to find out how this all goes in the next video. Sorry, my loves.